increasing intervals are the x values that make the function. So the function, that's how we describe an equation. We would say like the equation equals, or the function equals this. So if we had like down here, for example, 3, we would say like the function is 2 times the absolute value of x plus 1. So when we read it like that, we're really just using the function, that word. We're using it to describe the y value. So the function is the y value. So whenever they say the function, they're actually just talking about y. So increasing interval is the x values that make the function, aka the y value, go up. This is where the graph slants up to the right. This is where the graph slants up to the right. The decreasing interval is where the x values make the function, aka the y value, go down. This is where the graph slants down to the right. So in our notes, when we talked about domain and range yesterday, we said that the domain was x values, the range was y values. Quentin, did you leave something behind? What are you? Your charger? Where is it? Lily? Unless there's one left behind, I don't know that we have one left behind, but we can check for it tomorrow? Okay. All right, so the domain is the x values, the range is the y values, and then over here, increasing and decreasing interval, those are both x values, and so that's a good thing to remember, that so far of all the things we've covered, the only thing that has to do with y values is the range. Everything else has to do with x values, okay? All right, so if we look at this, we have increasing interval where the slant is up, decreasing interval where the slant is down. Okay, so what I like to do to make this make sense to my brain is I put a stick figure right here, and I think about if my stick figure is walking uphill or downhill. Okay, so if this stick figure started walking, is he walking up or is he walking down? Down. So if he's walking down, that means he is decreasing. He decreases, then he hits the vertex, and after he hits the vertex, what does he start doing? Walking uphill. He's increasing after that, walking uphill. Okay, now over here we have an arrow, and if we think in terms of left and right, this arrow would be a negative infinity or positive infinity. Negative infinity because it points to the left, okay? This arrow over here would be a negative or a positive? Positive infinity, okay? And then over here for the vertex, what would the x coordinate of the vertex be? 0. So I used x values for all of these because for increasing and decreasing intervals, we use x values. Okay, so now I'm going to write my answers for increasing and decreasing intervals using the numbers that are on either side of the word. So the word decreasing is in between negative infinity and 0. So I'm going to write negative infinity and 0. And then the word increasing is in between 0 and infinity. 0 and infinity. Okay. So we put a parenthesis for sure on the infinities, and then for the zeros, we only put a bracket if the stick figure is actively increasing or actively walking uphill at that exact point, okay? So if we look right here at the vertex, is the stick figure at the vertex right here, is he walking downhill? No, he's like at the bottom. Okay, so I'm going to put a parenthesis because he was not actively walking downhill when he was at the bottom of the V, okay? When the stick figure was at the bottom of the V, was he actively walking uphill? No. So parenthesis there as well. Okay, so that's supposed to be similar to the idea of what we talked about yesterday with domain and range, where yesterday I said I'm going to include the two if I can put my finger on it, if I can see it. That's kind of like I'm actively participating in that. I can see it. It's right there. Over here, if it's actively happening, then I put a bracket there. But if it's not actively happening, I do not put a bracket. Okay, so is he walking downhill? No, he's not actively walking downhill. He's kind of in a neutral space where he's in between downhill and uphill. You guys see how the bottom of the V is in between downhill and uphill? It's not one, it's not the other. It's kind of a neutral space. Does that make sense? Okay, so because it's a neutral space, it gets a parenthesis, not a bracket. Okay? All right, let's look at the next one. So this one, we put our little stick figure over here. Is he walking uphill or downhill? Uphill, okay. And then he gets to the vertex, and then once he goes over the vertex, which way is he walking? Downhill. Okay, so we have a left arrow, which is a negative infinity, and a right arrow, which is a positive infinity. And then what is the x-coordinate of the vertex? -5. Okay, so if I look at the word increasing is in between what two numbers? -infinity to -5. And the word decreasing is in between what two numbers? -5 to infinity. Okay, the infinities always get a parenthesis. Now, if we look at the top of the V, is the top of the V a moment where he is actively walking uphill? No. Is the top of the V a moment where he is actively walking downhill? No. It's kind of an in-between. When you're at the top of the V, you're not walking uphill, you're not walking downhill, you're kind of in a neutral space. You're in between uphill and downhill. You're not really doing either of those things. So we put parentheses. All right? Okay. So that's those two words, increasing and decreasing. The next two words that we're going to look at is maximum and minimum. So maximum is the location of the highest value of the function, aka the y. So the highest value that the function has, aka the biggest y value that you can see, and we write it as a point. Okay, now there are some ways that they can ask a question about the maximum where they don't want the point as an answer, they just want the x coordinate or they just want the y coordinate. So if they ask a question where they say where is the maximum, if they say where, they're actually asking about the x coordinate of the maximum. If they say where is the maximum located, they don't really want the whole point, they just want the x value. Could you answer with the whole point? Yes. You would be over answering the question. If somebody said, what is your name? And I gave them my first, middle, and last name, am I answering the question? Yes. Am I over answering the question? Yes, I am. I'm giving them too much information. Does that make sense? Okay. If somebody says, what is the maximum, then you're going to tell them just the y coordinate. Could you answer with the point, the x and the y coordinate? Yes, you would be over answering the question. So if they say where is the maximum, you could give just the x coordinate or you could give the whole point. If they said what is the maximum, you could give them just the y coordinate or the whole point. Okay? When I ask you for the maximum, I just want the whole point. I just want the x and the y coordinate. Just give me everything. Okay? Just to make it easy. All right. The minimum is the location of the lowest point of the function. written as x and y coordinates, written as a point, x and y coordinates. Same thing, they could ask a question about like where is the minimum of the graph, and if they said where, they would be asking for just the x coordinate. If they said what is the minimum of the graph, they would be asking for just the y coordinate. Okay, so example 5 says draw an example of an absolute value function with a maximum at 3, -2. So over here we want to go to 3, -2. We're going to make that a maximum. So if that's going to be the highest point of the graph, should that be a v that's normal like this, or should it be upside down like this? It's going to have to be upside down. So I'm going to draw it and make this an upside down V to show that that's the maximum of the graph. So I would say the max of the graph is 3, -2. And I would say the minimum of the graph is none, because for V-shaped graphs, they either have one or the other. They do not have both. This graph cannot have a minimum because it goes down forever. So there's no minimum if you're going down forever. All right, example 6, draw an example of an absolute value function with a minimum of your choosing. So it doesn't matter where you draw it, just draw a point anywhere. And then we're going to draw a V going up. So I drew my graph over here. So I'm going to say for my maximum, I have none. There is no max for this graph. And then for the minimum, I'm going to say that my minimum is -5, 3. And that's it. Okay. So in the packet of questions, we've done 1 through 20. The questions that you could do today, now you could do the first part of 21 and 22. You could say what the increasing and decreasing intervals are for 21 and 22, and you could find the answers for 23 and 24, max and min, and the transformations. So let's go ahead and draw a sketch for 21 and 22. So that we have a picture to work with so that we can draw our stick figures. So for 21, it has a positive 1/2 in the front. So should our V be going up? Should it be opening up, or should it be opening down? Should be opening up. So here's our V. Okay. And could somebody tell me what the vertex is for this V? It is, Julian, what did you say? -5, +3? Perfect. Okay. And then for 22, is that V shape going up or is it going down? It's going up because there's no negative in the front. So this V shape is going up. And then what is the vertex on this graph? 2, -1. Okay. Okay. So right now we're going to work on 21, 22, 23, and 24. For 21 and 22, you don't know yet what continuous means, so we can come back to that definition later, but you could at least do increasing and decreasing. Okay? So take a moment to work on those 4 problems, and then we'll go back to the solving inequalities when we're done with these. All right, example 3. Example 3. Okay. 5 minus 7 times the absolute value of -9x plus 10 is greater than -51. Okay, if I look at the problem right now, Can I tell right now if it's a less than or a greater problem?
Yeah.
Can I tell?
Oh, no.
No. Why not? Because you have stuff that you have to do. What is the point that you're supposed to be able to check it? When the absolute value is by itself, that's when you know. Okay? So you have to wait until you've done a few steps and then you can check it, or else you could know at this point, but you'd have to like mentally do some math first to be able to check it. Okay. Our first step is, can we add or subtract some stuff to the other side? To start to get the absolute value alone, we can subtract the 5 over. Let's do that. Okay. And then our next step is what? Divide by the -7. And when we divide by the -7, what should we do? We should flip the sign. So anytime we're doing absolute value, or not absolute value, anytime we're doing inequalities and we multiply or divide by a negative, we have to flip the sign. And -56 divided by -7 is 8. Okay. So because this is a +8, we can continue with the problem. What would have happened if it had been a -8? We would have stopped. We would have said no solution. Thank goodness I don't have to do this problem. But it's a +8, so we do. So what symbol do we have here? Less than. So what kind of answer are we going to have? A sandwich. Okay, so I'm going to have an X in the middle, and then I'm going to have a sandwich. And when you write your sandwich, your little symbols match the symbol here. They both go the same way. Okay? So we're going to have less than, we're going to have a sandwich. Okay. And now I can kind of ignore that for a second. I can go off to the side. I can do my work. And so how do I do my work? Yeah, I pretend that I'm solving an equation just like I did before. So I say I'm going to do the negative version of the inside. The negative version of the inside could have had a distance of 8 from 0. So that could have equaled 8. Or the regular version of the inside could have equaled 8. And that's how they got 8 on the other side. So it could have been the negative version or the regular version to get that 8. All right, and then what should I do? Solve them, yeah. What do you guys want to do first? Which one? The negative? Okay, so we'll distribute the negative. And what do we get? 9x minus 10 equals 8. And we'll go ahead and add the 10 over. And we get 9x equals 18. And so what does x equal? X equals 2. And then do I automatically just go and put a 2 in here? No. What should I do? Find the other one. So I have to be careful here. I'm going to wait until I've completely done the problem, found both answers, because I have to make sure that the smaller one gets put over here. Right, Dalton? Are you just swiping your page like this? Just swiping the page up? Just checking. All right. What should we do over here? I was making fun of it because I could tell you were on your phone. That's why. All right. Minus 10. And then what should we do? Equals -2. Divide by -9. And x equals 2/9. Okay. Between those two answers, which one is smaller? 2/9. Okay, so 2/9 is going to go over here. And then 2 is going to go right there. So we just have to make sure we get the smaller answer to go on the left side. All right, another example. Example 4. I'm probably going to run out of space. We'll see if I can do it. Example 4 says 8 minus 9 times the absolute value of 6n minus 4 is less than -10. Say it again. So the first thing we should do is subtract the 8. All right, and then what do we do next? Divide by -9. And which direction is our symbol going? Greater than. This is a greater than symbol now. And so if this is a greater symbol, greater, then that means for my answers, I'm going to have x is less than one number or x is greater than the other number. So my arrows are pointing opposite directions. Okay? So in one option, we have the sandwich where both symbols match this. Or the other option is where they're pointing the opposite directions. Okay? That's all you have to remember with the symbols. Okay, so now to find our numbers, what should we do? Positive and the negative version, just solve it like we did with equations. So we're going to say the negative version could have equaled to -6n minus 4. Or where should I put? I'll put the positive version over here. Okay. So I'm going to go ahead and do the negative version first. -6n plus 4 equals 2. Minus 4. And what are you guys getting for the n value? N equals 1/3. Okay. Save that answer. All right, and then over here, I'm going to add the 4. 6n equals 6. And so what does this n equal? Okay, so when I go over to put my numbers, I'm going to say x is less than 1/3 because that's the smaller number, or x is greater than 1. X is less than the smaller number, or x is greater than the bigger number. Okay. How do you guys feel about those problems? Do we understand how the absolute value part of it works? Okay, so either a sandwich or they go opposite directions. Okay, the way that we're going to practice these problems